This is the HMI and simulation program. It simulates a temperature. Here's the PLC. It's a SoftLogix L60. So I'm not using the Ethernet. I'm just using the virtual desktop. Here we have a SoftLogix processor I'm using, and slot 6, and remove this. This is just not working right. I'm not using this right now. Right now I'm just using the SoftLogix processor, and the topic for the OPC is set to Unit 2000 L60, and you see it's linked, and it's set for 100 milliseconds. And I'm just using the virtual backplane for communications. That way it can go from PC to PC, and you don't have to worry about the Ethernet address. If we look here at the program, I have my function generators. These were generated to generate a sine wave and a square wave. So I generate a square wave, and the square wave will actually go through a lead leg in the function generator, and it'll actually create a sine wave with the lead leg. So 2 function generators, and they're changing from plus minus 1, and these create disturbances, which I use in a different process. I'll show you later. So it goes positive 1, negative 1, and then here's the function generator, and you'll see what's coming out of the function generator. This is in the main program because it's not important how quickly it changes. Why I have a 100 millisecond periodic over here for all the analogs. So here's the 2 function generators. We come into the lead leg, go through the dead time, come out of the lead leg, and you'll see how we're generating a sine wave. It's generating plus minus 20, and this one here is plus minus 1. I don't know if I have this plotted or not. Oh well. Let's just go to the come back to them. Well, there's the function generators. I don't know why the sine waves aren't running. These are ladder control for agitators and pumps. Pump programs are separate. And then here we have our process simulation. And here I have, in this one here, you'll see these are flows. It flows in and out, and it has an accumulated level for a flow in and out. And then I have a level indicator. It's a level indicating controller, and then I have a ladder to control it, which is pretty simple. But here's the function block for the level. Now the function block for the level, as it's running here, what we have is you have a set point, which is set at 7.5. It's 0 to 20 feet. I can put in 0 to 20 feet. So it's set to 7.5, and that's where we're at right there. Then this is the hand switch for the valve, and it switches us between hand in auto mode, and then we load in our safe position for off when it's off, and this turns the controller off and on with the hand or auto mode. But we take our process variable here, and it's coming through all this stuff. Okay, all we do is we take the set point, we have an output, the output comes around here, and then the output goes to scale. And we take 0 to 100%. I got this output scaled at 0 to 100%. So it's scaled for the output of 0 to 100%. So we want an input of 0 to 20 feet. So what we do is we bring the output around, go through our scale, and we have our engineering value here of, actually I've set it to 15 feet maximum. It was 20. So the raw value coming in is 100, but we make it a max of 15. So 15 instead of 20, which is less than the process variable maximum, so that's good. So it's 0 to 15 input here. That allows us to, when your process is oscillating back and forth in hunting, it can go above the 15 set point and go up to 20, and that allows the input to show you your oscillations when you're poorly tuned. Okay, then we take that 0 to 20 out, and it's going to be 15 maximum. We've set it to 15 maximum. You see it goes up to 15 maximum. It's just oscillating back and forth because it's poorly tuned right now. And you bring that into your dead time. And here we have a dead time tag that says how many seconds of dead time. And that dead time will actually set, and we also have a gain of how much gain, a process gain. This gives us a process gain. And I set this between like 0.75 and 1. You might want to get down to 0.5. You might want to go up to 2. It depends on how much your process gain would normally have. I think I have mine set to 0.75 for the, I got it set to 1 for the level and 0.75 for the temperature for a gain. Then we come out of the dead time. This has a dead time array, and this has a dead time array of 100. I think I put in an array of 100 here. So here we have the N. We have the dead time is set to 4, set to 4 seconds. The gain is set to 1. And here's your output as it goes through the array. And I'm sure it created an array of 100. And then we come into the leg. Here I'm using the lead leg. I'm using the leg on this. And on the leg here, I've got 5 seconds set. This is coming off this tag right here that you can put in. You can program any dead time, loop gain, or leg time you want for these loops to simulate. So this is the leg time of 5 seconds. It takes 5 seconds to integrate up, and this acts as an integrator. And here's your output coming in from the dead time, and then here's your output from the leg, and you see it legs. It takes a while for it to get up there. It lags behind the dead time, and so it integrates the process. As you see the variables here, it lags behind and integrates. Then we come out of there and we come into our process variable, and that's our level controller. That's our level controller. Now, for our temperature controller is a little more complex. We'll start down here at the bottom, start at this line right here down. This is the temperature controller. And we set this to, here's our set point, and it's 0 to 200 degrees. And we've got it set for 100 degrees. And we come out of there and we get 0 to 100%. Even though we can scale this variable, this is just the CV itself. So it's 0 to 100%. And we take this over, we go into a scale, and it takes 0 to 100 and it scales it to 200. So our engineering max, our raw input is 100, and our engineering max is 200. So we come out of there and we come into here, and this is where the top comes in, but we'll look at that in a minute. What we're doing is we're adding a temperature disturbance right here. We're taking the temperature out of the process from the PV and our measurement, and we're adding a disturbance for the outside temperature, where the temperature can get lower and go down to 32 degrees, or it could go up to 120 degrees for an outside, say inside a building. We'll talk about this temperature in a second. We come from here, we go into our dead time, same thing again. Got a dead time array of 100. Dead time array of 100. It's called TD100 dead time. Where is TD100 dead time? Right here. And it's an array of 100. Yeah, I set them both to an array of 100. They're a real of 100, an array of 100. So that's the dead time. Come back to the temperature controller. And so we got a dead time of 100, an array of 100. It's shifting through slowly. And the time it takes to go through there is based on the parameter of the dead time, and this is set to 4 seconds right now. So it's a dead time, 4 seconds to propagate through the dead time, and it has a gain of 0.75. So it kind of dampens a little bit because your heat going into your through your wall and you're absorbing into your liquid takes a little time. So I gave it a gain of 0.75 for the dead time. Then we go to the lead leg, and here's your leg time. Here's your dead time tag. Here's your leg time tag. Comes in here, and then we come out of this lead leg, and we go to our process variable. I've also got it going to a high-low limit, which sets this where I don't go below 0. So with the high-low limit, I don't go below 0. I set the low limit to 0, so I don't get a minus 0.15 or a minus 0.1. Instead of seeing that, it stays between 0 and 100 because the temperature will never go to a minus like that. So this is my tag for my temperature. This is the temperature tag. Okay, let's look at the HMI. Okay, it's running already. So here, and what you see is right now it's in auto mode. So it's poorly tuned, and it's in auto mode. So it's just oscillating back and forth, back and forth, back and forth. And the temperature doesn't come on until this is 40% of its height. At 40% of its height, the temperature controller will be enabled to make sure there's liquid in the tank. So when it comes down, temperature goes off and it's disabled. And when you get over 40% in the tank, then the temperature is enabled again. And you notice the valve goes green. So right now they're in auto mode and they're poorly tuned. So they're just oscillating away. Here's the outside temperature, 60 degrees. Okay. And here's the temperature disturbance where we can add plus minus. It says plus minus 70 on the on the program, but I really set it to plus minus 60 in the HMI, so it's not 70, it's actually 60. I should change that. So this gives you plus minus 60, and it doesn't just give you a temperature, but it ramps up that temperature over time. We take this time right here in minutes to change the temperature from 0.1 to 60 seconds. Minutes. This is minutes. 0.1 to 60 minutes. So in the HMI, it's in minutes, but in the PLC, it'll be seconds. So I take that disturbance coming in, this takes the disturbance, and this is the minutes to reach full time, and here's our disturbance, and remember it's plus minus 60, not 70, plus minus 60. I take the minutes that you come in, I multiply it by 60 to change it into seconds, and that's my leg time, and that'll be the leg time in here. So right now it's set, the leg time set to 6 seconds. 6 seconds. So after that, we come out of there, and then we add the outside temperature, which is 60 degrees. So we have this outside temperature set to 60 degrees in our variables. And from there, we take the ramp disturbance. This is the ramp disturbance coming out. It's a ramped up disturbance because it's coming out and it ramps up slowly, slowly, slowly. The disturbance ramps up. I take that ramp disturbance, that's just the tag, and I bring that into the source here, and we add that to the temperature of the process. So say it's 60 degrees and you got it at 100 degrees, and then all of a sudden the temperature comes in, a storm comes in, and it comes down to like 30 degrees. You're not going to be able to maintain that 200 degrees. It's going to start dropping off and dropping off and dropping off and dropping off. So we add a disturbance, and we find out what the limitations of our energy going into our temperature is with our disturbance right here. So that shows how all these programs work. Let's just go back to the HMI. Okay, you see the pump's running. We can stop the pump. If we stop the pump, it'll empty out. And then the heater goes off. So the tank drains out. So it's a pretty good simulation. It's fairly realistic. We'll start to pump back up again. You'll see it go green, and you'll see the valve position here opening up to 100%, and you'll see it going up, and then it'll start oscillating. And it'll start oscillating back and forth because it's poorly tuned. And then you'll see the temperature come off and on, off and on, off and on, off and on. As it goes up over 40%, I believe I made it 40%, it could have been 20%. It looks like more than 20% actually. I'll have to go back and look at it. But it starts oscillating back and forth, back and forth, back and forth. Now we can put this in manual mode, hand mode, and these will stabilize. Okay, so this is going to stabilize at 7.5 feet because that's what it was designed for, 50%. And this will stabilize at about 80 degrees at 50% flow. Okay, we're in hand mode. Our set point is 7.5. We're in hand mode. We're at 50% valve opening, and you can see we're at 50% here. This would be 10 or 100%. This would be 200, and this would be 20. This is actually our level here. So we're going 0, 7.5 feet, 12 feet, got 10 feet here. 16 feet and 20 feet, and remember we set it to 15 feet maximum set point, so 15 feet maximum set point right here, and this is for oscillations for settling in. And so right now we're at 7.5 and our valves at 50% open, because this would be 100 and 200%, so this would be 50% open. And here we're at just a little below 80 on manual set point. If we go to tuning, okay, I clicked on tuning. Now we got our tuning in here. This is another HMI that has the tuning in it. and we have a poor tuning and good tuning, so you can demonstrate the difference between it. So let's take it out in hand mode, put it back in auto mode, and let's make a set point change. I'll make it 10. Whoops. 10. Then you'll see it'll start oscillating again. Because right now it's steady. At manual we set it steady to 7.5 and it was steady. So now we made a set point change to 10. And now it's poorly tuned, so now it'll start oscillating. Just let it oscillate for a minute. And I got both valves in auto mode now. So they're both oscillating. Okay. Okay, now we hit good tuning, and it'll tune in. Hit good tuning for the level. And I'll go ahead and hit good tuning for the temperature because we're running now. Now notice we have the gains changed here, but notice I got a dead time of 4 seconds and a lag time of 5 seconds. And over here, I got 0.12 for my proportional gain, 0.026 for my integral gain, and 0.04 for my derivative gain. And as you see, we tuned right in. It tuned right in. If I put it back on poor tuning and make a set point change, we're stable right now, so I'll put it back to 7.5. And you'll see it becomes very unstable. This one here is almost, temperature is almost tuned in. Temperature is almost tuned in. Temperature has a lag time of 60 seconds and a dead time of 4 seconds. So it has a lag time of 60 seconds. So it takes a while for the temperature to tune in. But it's almost there. It's almost there. Okay, so let's go ahead and put in, here we got a gain of 1, a 0.028, and no derivative. Let's put in good tuning and watch it tune in. It'll tune in pretty quick. So you see our set point's red. You'll see we've been on a set point for quite a while. Temperature set point is on the money, and with this temperature that's going on, you'll see the valve still oscillating back and forth a little bit, but it's becoming pretty stable now. This here is the process variable right here, and here's our valve position, and here's our set point. So we've been on set point for, I don't know, 30 seconds now, and we're just now starting to actually come in and tune in. This could be tuned a little better, but it's got a 60-second lag time. If we change the lag time, it'll tune in a lot faster. if I change this leg time to say 6 seconds, just respond a lot quicker. It was just now starting to tune in. As you can see the phase shift in it. You can see the phase shift around here, and you can see how it was starting to tune in, but it's going to tune in faster now because I put the time down to 6 seconds, from 60 seconds to 6 seconds. And there's our process variable, and it's almost right on our set point already. So we're on set point already, going to 6 seconds instead of 60. If we put in 30 seconds and made a set point change, it would take a while to get into set point. It'll take a while to do that. Up here in our level loop, we can make a set point change. Now that we're tuned, we can make a set point change and it'll just tune right in. So I'll put in 10 and hit OK, download, and I'll set to 10. So our set point is the red, and it just went to 10. And the blue is our process variable, and the black is our valve. And you'll see we'll tune right in with quarter amplitude dampening. And it's very tight. It's a pretty tight tuning right here. So there's not going to be much oscillation. Okay, we're practically tuned in already. Now I did this with manual tuning. I didn't use auto tune. Auto tune didn't tune very well, in my opinion. It did okay, but it was very sluggish and very slow with the tuning. So I tuned this by hand using the charts. As you see, we're already in, our set point is already on, process variable is already on set point. And we'll make a temperature change. So let's put a temperature change at 0 to 200 degrees. 200 degrees. And we'll make it 150. And download. And I've set my leg time to 30 seconds. So here's our temperature tuning in. This is our process variables, our blue. Our set point is our red. And our valve position is our black. So we're 100% open on the valve. Process variables coming up. Process variables coming into set point. Let's make this fast. Let's give our minutes for temperature. Let's give it. I'll just leave it at 0.1. Let's just leave it at 0.1. And let's go ahead and give it a disturbance. We're already tuned in here. I'm going to give it a disturbance of minus 30 degrees. So green is our disturbance. So it was at 60. It's supposed to be at 60 degrees, which is half of this. And now we've added. It was supposed to be at 0, 0, which would be in the center, but now we've gone minus 30. So the disturbance was 0 degrees, but now it's come down to 30. We take this and cut this in half, and then we get, so it'd be 10, 20, 30, 35, almost 35 degrees. Now our process variable is dropping off. We can't keep up because our valve's at 100% open. We'll have to lower our temperature down. So if we lower our temperature down to 100 degrees, now our valve can close down. So we were maintaining the temperature at 150 degrees as long as the temperature outside was 60. But when the temperature dropped down to 35 degrees, the outside temperature now is 25.2. It just couldn't generate enough heat to bring it into set point. But now we've lowered the set point and we don't need as much heat. Now it'll tune in. See the valve opening up a little bit more to bring it back up because we went under. So we're under the set point right here with the process variable. So the valve's opening back up. And we should have quarter amplitude dampening on this one. I use the Ziegler-Nicholas tuning. Remember, this time constant right here, this leg time is set to 30 seconds. 30 seconds for this heat to go in, get through the metal, you're going through here, you're going through your heat exchanger, and then you're going in here and you're heating this up with this temperature coming through the metal, trying to cool it down. So it's pretty good. It's responding pretty quick. And we're already at set point, and we'll get a little overshoot, and then it'll bring it back down again. And so you should have 4 oscillations before you actually come in and tune in. But they're going to be so insignificant with the overshoot that you won't even really notice it. Just the first one. And our temperature is 101.1. Now it's 100.9 and coming down. It's nearing in. It's tuning in pretty good. Hundred 100 degrees. We're at 99.9. It should pull right back up. 99.8. .7. .8. .9. We should be hitting 100 now. 100, there it is. we're tuned in. Okay, that's about it for this one right here. This one here is a difference of first this tank has to fill up a little bit, and then the pump will start pumping. I think I set it at the 10% level before it starts pumping. There it goes. This takes the accumulation of the two flows, and I have a disturbance in these two. And you can see the noise right here in the set point. Here's load disturbance. This is a load disturbance coming out of the process upstream, and the load disturbance in gallons per minute. You can see the set point changing based on the load disturbance of the gallons per minute. This here has a disturbance on the bottom too. You'll see the noise right here. These are what the function generators are doing. The function generators are making these sines and these sine waves right here. And this is a sine wave as well. And it's just a really small amplitude. Okay, let me change this set point here from 200, set it down to 150. Say the demand down the line isn't as great, then the surge tank will start taking in the extra flow, and it'll start building up here. Let me put this in automatic mode. It's in hand mode. Put it in automatic mode, sorry. I haven't done these tuning parameters on this yet. I haven't got around to that. But it's got the old tuning parameters in it, and so it should be close enough. It should tune pretty well. I'm putting good tuning. It's got good tunings in them already. So that'll tune in pretty well. It's not tuned correctly, but it's tuned, kind of. And you'll see it comes into the set point pretty quick. If I put in port tuning parameters, I haven't done these, yeah, these are the old tuning parameters. And they're both the same because I haven't programmed these yet. I haven't got into these. But there's port tuning. There's good tuning. It'll be tighter with good tuning. You can see the noise on the valve, and you can see the noise on the process variable here. You can see the noise on it, where you have like pump pulsations creating noise, and we also have our load disturbance here. The process may be upset a little bit, and so the flow out is a little less or a little more than 200, you know, depending on what you're trying to set it to. So I've got it set to 20 gallons a minute, plus or minus 20 gallons a minute here as a load disturbance. Just to show load disturbance. And you can see the tank here has accumulated 151 gallons and levels at 15.3%. If I stop this tank, you'll see I'll stop this pump, you'll see the tank starts filling up. This one here hasn't finished, I haven't finished programming this one completely, but it's pretty good. So you can see the tank just filling up, filling up, filling up, filling up. And then I'll start the pump. Let's stop this one. And you'll see the tank will start emptying out. Okay, that's about it. I have one more that I haven't set up here. It's not really a simulation. It's just to show fill. It's just a bang bang fill and unfill. And I haven't set up the processor for it yet. We'd have to have to load the program. And I believe I put that in slot 2, so it should work. 1000 tank empty fill. It's not really a process simulation. It's just a bang bang simulation of up and down and filling and emptying tanks, and then download it. Continue. Okay. Run mode. And here we have so now it's L10 unit 1000, and if we go to topic, OPC topic, you'll see 1000 here, and we go to 1000 and apply. We'll update it in data. 100 milliseconds is already set. Done. Let me close this out. Okay, let's start up the HMI. And this one here doesn't have home on it. Let me stop this here. Unit 1000. I think this works. I believe the OPC will still work. Okay. Okay, and then start. And you can see it fills. We'll turn the alarm on. And you get an alarm it's full, and it shuts down. Then you can open the valve, you can empty it. And say you start to pump again, it'll say close the valve first. So you close the valve, and then you start to pump, and it'll fill up again. Or you can open the valve and drain it. It'll stop the pump when you open the valve. And then it'll give you a tank empty alarm also. And there's your tank empty alarm. Level tank 100 empty. Close the valve, start it up again. And it'll fill again. And you can fill and empty it from any position. So it doesn't have to just fill up all the way and empty all the way. You can do it from anywhere. So it's kind of cool. I did this with timers and scaling the timers. And subtract from the accumulated values of the timers. So as you're timing to empty, and then the timing that it takes depends on how many gallons you got in there. So right now we got 10,000. If I put in 100,000, and then start it, it takes longer to fill up the tank, and you can see the gallons change, and you notice the height of the tank changed from 20 feet to 50 feet. You can get down to 1,000 feet. I'll stop it, reset the project, put in 1,000, download that. You see it's only a 10-foot high tank with 0 gallons in it now. We've reset it. You start it, and then it fills a lot faster. It fills faster based on the size of the tank. So it's pretty good for students. It's a pretty good simulation. And again, you get full, empty thing. So it fills and empties based on the size of the tank at a speed that's based on the size of the tank. And when you get empty, you'll get your empty again here, your empty alarm. That's about it. That's as far as I've got for this project. Okay. I'll see you later.